Hello, in this lecture we will study the following topics, that is about the photons, photoelectric effect, experimental setup to study the photoelectric effect, effect of intensity, frequency, potential etc. on the photoelectric current, graphical representation of variation of photoelectric current, laws of photoelectric effect, Einstein's photoelectric equation, verification of the laws of the photoelectric effect, application of the photoelectric effect, matter waves. Now we start with the photons. The phenomena like the interference, diffraction, etc. proved that the light consists of the wave nature. But the phenomena like a photoelectric effect cannot be explained on the basis of the wave nature of light. This phenomena, photoelectric effect, can be explained if we consider that the light is made up of particles. And these particles or the packets of the energy of the light waves are called photon. So what is a photon? Photon is a bundle of energy. If the frequency of the light is nu, then the energy of the photon equals to h into nu. As you know the relation that C is equal to nu lambda. So nu is equal to C upon lambda. So the energy can be obtained by using the relation either h nu or hc upon lambda. Now let us discuss the properties of the photon. Photon travels with the speed of the light in vacuum. Rest mass of the photon is zero. According to the theory of relativity, mass varies according to the relation. As the photon moves with the speed of the light, that is V is equal to C, this factor is equal to 0, so m0 is equal to 0. That it will not exist at rest. The kinetic mass of the photon means when particle is in motion is given by this relation, where C is the speed of light. The momentum of the photon is given by E upon C or h upon lambda. Photon travels in a straight line. Energy of the photon depends on the frequency of the light. As already I told you that E is equal to h nu. It depends on the frequency of light. So the energy of the photon does not change when it goes from one medium to another medium, as the frequency of the light remains same when it travels from one medium to another medium. So we can say there is no change in the energy of the photon as it goes from one medium to another medium. But the wavelength of the photon is different in different media. So we can say the velocity of the photon is also different in different media. Photons are electrically neutral. It undergoes the phenomena of diffraction. As they are electrically neutral, so these are not deviated by the electric and the magnetic fields. So these are the some of the properties of the photons. Now we come to the main topic, that is a photoelectric effect. You know, whenever the light is incident on the surface of the metal, electrons are coming out. And if we make some arrangement so that it constitutes the current, then this effect is called photoelectric effect. So what is the photoelectric effect? Phenomena of emission of electron from the surface of the metal when it exposed to the electromagnetic radiations of suitable frequency is known as photoelectric effect. The electrons emitted are called photoelectrons and the current is called photoelectric current. As the metals, when are exposed to the ultraviolet radiations, it gives out photoelectrons. Alkali metals have very low function. They give out the electrons even when exposed to the visible light. Now the experimental setup to study the photoelectric effect. To study the photoelectric effect, a evacuated quartz tube, it is a quartz or made up of a glass tube, is used. C is a cathode which is in a semi-cylindrical shape and is made up of a photosensitive material. W is a window through which the light radiations or the electromagnetic radiation enters and is incident on the cathode. A is a anode, and these are connected with a potential divider so that the potential at the anode may be positive and may be negative with respect to the cathode. K is a switch or the key. Microammeter is connected in this circuit because the very small amount of the current is flowing in this process and cannot be used as such. It is first amplified, its magnitude first increases and then it is used. V is a voltmeter. Now the light radiation is incident on the cathode and the electrons are produced. This electrons passes through the anode and constitutes the current. When the light of the suitable frequency falls on the cathode, photoelectrons are emitted. These are attracted towards the positive anode and hence the photoelectric current is produced. Now the effect of intensity of the incident light on the photoelectric current. It is observed that when the light radiation of fixed frequency is incident on a surface, incident on a cathode, then the photoelectric current is produced. And it is observed that with the increase in the intensity, the photoelectric current also increases. And this graph, when a graph is plotted, this graph is a straight line graph passing through the origin. It means the photoelectric current increases linearly with the increase in the intensity of the incident light. Now it is the effect of potential on the photoelectric current. Now, when a light radiation of fixed frequency and intensity is incident on the cathode and the potential is increased gradually, potential of the anode is increased gradually, then the shape of the graph is like this. As the potential increases, current increases and then it becomes saturated. This maximum value of the current is called saturation current. When the intensity of the light increases, the value of the saturation current increases. But it is observed that when the potential of the anode is negative and the value of the negative potential increases, then the amount of the photoelectric current decreases and it becomes zero. The potential of the anode at which the photoelectric current becomes zero is called stopping potential. So what is the stopping potential? The stopping potential is the potential of the anode, negative potential of the anode at which the photoelectric current becomes zero. Thank you.